Hello and welcome to my mini system design lecture. This one focuses on powered versus unpowered loudspeakers and active versus passive crossovers. There's essentially two types of speakers in the world, those with amplifiers inside and those with amplifiers outside. The traditional speaker has the amplifier outside preceding it, so the console output comes out at line level, goes to the amplifier raises voltage and current to speaker level, goes to the speaker, and the speaker inside this enclosure has a passive crossover, and the crossover is a set of filters. It sends the highs to the tweeter and the lows to the woofer. Now this is called an unpowered loudspeaker. I will confusingly often call this a passive loudspeaker because it isn't self-passive. It does not have an amplifier inside. It is not connected to wall, power, or AC mains. It's a passive thing. But I try to call it unpowered, but I will call it passive. And why does this matter? Well, it can be kind of confusing when we're talking about passive loudspeakers that may have a passive crossover or may have an active loud. It's the confusion between passive crossovers and passive speakers and active crossovers. So anyway, bear with me as I try to call these unpowered speakers. Now, an alternative to this is the powered speaker, and the powered speaker has the amplifier inside of it, and that's really its definition. And powered speakers may also be called active speakers. Now, there are some significant advantages to both of these paradigms. The unpowered loudspeaker, it gives you a choice of amplifiers. This can be really useful for some people, some sound companies. Some people prefer a certain brand or a certain design, so this lets them use a different loudspeaker than their different speaker and amplifier selection and choice. The biggest one for me, why I really like passive loudspeakers, is less onstage cabling. All you got to do is run a speaker cable. You don't have to run a power cable as well to the box. And I really, really prefer this when it comes to stage wedges because I don't want to have AC power running all over the stage too. It's just complicated. Now, when it comes to arrays and flying speakers up in the air, passive loudspeakers, passive line arrays are often preferred because you don't have to send the amplifier up in the air. Amplifiers can be heavy, which can significantly create additional rigging requirements. It can also be maintenance issues if the amplifier fails when it's up in the air. Regarding amplifier failure, another nicety of unpowered loudspeakers is that when the amplifier fails, you can just swap a new one and the speaker stays in position. Where with a powered loudspeaker, when the amp fails, the entire speaker fails. In contrast to this are the pros to powered loudspeakers, and there are plenty of them. A big one is you don't have to have amplifiers. You don't have to buy them. It can save you a lot of money. You don't have to transform them. You don't have to store them. You don't have to power them. So this can be a real plus. The amplifiers can be more efficient. There's less power wasted because the amplifiers can be specifically designed for the driver it's facing. Kind of associated with this, power loss is minimized because you don't have to lose a lot of power over distance through long speaker wires, which is a problem with passive speakers, with unpowered speakers. And, bass may actually sound better with a powered loudspeaker because the driver and the amplifier are closer to each other, which improves damping factor, a better impedance coupling between the two. And we also can have better protection circuits, internal amplifiers. If you're going to have an internal amplifier inside a box, it's not hard to add a little circuitry that works as a limiter that can really protect the drivers from being fried. And then overall sound quality could be superior with powered loudspeakers because you can have active crossovers. These are line level based crossovers, which typically are superior for a variety of reasons, as I will get to in a moment. What is a crossover? You probably already know. A better term for it is frequency dividing network. It divides the frequencies, so using a pair of filters, so lows can go to the woofer and the highs can go to the tweeter. Now, this is assuming, of course, a two-way system. Systems can be three-way, four-way, or even greater, and can use a set of high-pass and low-pass filters. So that's what a crossover is, and I want to dive into the two main families of crossovers. Just like the speakers themselves, there are powered and unpowered crossovers. I'm going to call them passive and active crossovers. A passive crossover is the one that's inside, typically found inside a unpowered loudspeaker. It works at speaker level, so you can really see the system design blocks here. Mixer goes into loudspeaker, processor goes into power amp. Power amp drives the loudspeaker at speaker level, and then the passive crossover splits, in this case, highs and lows apart. An active system does it at line level. Output of the mixer through the loudspeaker processor, the EQ, and the crossover at line level, XLR in and out, and it's an active device. It's going to be plugged into the wall. It's going to have low-level electronics, not high-level like here, and it's going to split the lows and the highs to 2 amplifiers, and this is a big one here. This guy, the passive crossover, requires a single amplifier, but an active is going to require at least 2 because it's splitting it. And then in reality, most sound systems use a combination of the two. In this case, we have an active crossover sending out to the subs and to the mains, and the mains have a passive crossover built in. And this is pretty common to see a combination of active and passive in most sound systems. So let's look at passive for a moment. In this case, we've got an amplifier preceding a loudspeaker. So this is an unpowered speaker because the power is out here. And inside this unpowered speaker, we have a passive crossover, a high pass and a low pass filter. And it's functioning at speaker level. So it's getting kind of warm in there, right? It's heating up. Now, an alternative approach is the active crossover. Now we've got the crossover before the amps. And that's really the big one here, is that console input into this powered loudspeaker with an active crossover, XLR input, high pass, low pass crossover network, and that's doing it at line level, which is got some real pluses in the circuitry. And we've got a separate tweeter amp and a woofer amp. So now we're actually bi-amped. You're using 2 amps. And this is really common. This is probably the most common powered loudspeaker model. Most studio monitors, most two-way powered boxes look like this as far as a block diagram. Another way that this might happen is using an external power amp. So now we really have an unpowered loudspeaker, but we have a smart amplifier. It's a DSP-equipped power amplifier. It's got the high pass and the low pass crossover network. In modern amps today, this would be digital, so it's DSP driven, although an older amp you may actually find analog filters, but most of the ones we see and the ones we see at Nescom, it's DSP equipped. And in this situation, you need to go to your amplifier and make sure you pull up the right preset. Here at Nescom, we pull up the bi-amp preset, and now the lows are going to go to the lows and the highs are going to the highs. Now, what's not really showing here is that it kind of indicates that there's 2 speaker wires, but in reality, you're going to want to have a 4-conductor speaker wire. So the positive and negative of the woofer amp can, which is 2 conductors, can drive the woofer, and the positive and negative of the tweeter amp can drive the tweeter. So you need 4 conductors in here in this speaker wire to drive these the 2 drivers. Okay, looking again. Oh, here is a even more complicated system where you would have an actual loudspeaker processor. So now the console output goes into a loudspeaker processor. It's working. Most of these are digital. There are older analog ones, but most of them here at Nescom are digital. And you've tweeter high pass and your low pass, then line level output, probably a pair of XLRs going into an amplifier. In this case, the amplifier is dumb, and it just does tweeter amplifier and woofer amplifier, so 2 channels in the amp, and off to the speaker enclosure. And again, this would probably be a shared wire, a shared cable of 4-conductor wiring. So, multi-amping. Let's give some Nescom examples and how this works. When you have a truly unpowered box with a passive crossover, it doesn't require 2 amplifiers. In this case, what's the Nescom MRX 512, it's a pretty cheap little wedge we have. They're the smaller ones. It is 2 speakers with a passive crossover inside, and you drive it with 1 amplifier. So it's single amped passive crossover, and it's not a very great speaker. Alternative to that, the exact opposite would be our VRX we have at Nescom. This is completely powered and active. So there are 2 amplifiers in there driving, one driving the lows, one driving the highs. I think there's 2 amps. There may be more, but I know there's at least 2. And it's a two-way crossover inside of it. And the crossover is active. It's working at line level. You plug into it with an XLR, and it does the internal splitting of the frequencies and amplification across 2 amplifiers. Now, the odd one is our VRX 915Ms. This is a stage wedge that can be either this or something like that. It's a little confusing. It can do, there's a switch on the side where you can switch between active and passive crossovers. Either way, there is no amplifier built into this thing. It is a unpowered loudspeaker, but you have a choice on how you deal with the crossover. Here's the side view of that unit. You can see the switch. You've got biamp and passive. Now what this does, when it's in this mode passive, you plug into the box and it will split using the internal high-level passive crossover. It'll split the highs to the tweeter and to the horn and the lows to the woofer. All you need is a 2-conductor speaker cable, so NL2 would be typical, and you only need 1 power amplifier. If you switch it to biamp, now it disables the internal crossover inside of this thing, and you need to use an external crossover. So in that situation, you'd use a smart amplifier, and you'd go to 2 channels, and you'd come in here with a 4-conductor cable. So the highs and the lows are both full speaker level, but they're coming in on over 4 conductors and on a bigger speaker wire. So it basically turns the internal crossover on or off. That's what this switch does. Here's kind of a picture of the 2 modes. Here is passive mode, where console output into 1 channel of the amplifier. You can use a 2-conductor cabling. At Nescom, we've got them labeled NL2 and NL4. That's the name of the connector. NL2 is all you need. NL4 will work, but NL2 is all you need. Then you go into the box, you're in the passive switch, and you're using the internal crossover. If you switch it to active, now you're using an external amplifier which has an active crossover. In this case, at Nescom, we use the DSB equipped crown amps. You switch it to the right preset, so it's biamp. It's doing its crossover. It's using 2 channels of the amplifier. And in blue here, I'm indicating that this is actually 1 speaker wire cable that's got 4 wires in it. 2 for the tweeter and 2 for the woofer. The 4 is what you see there for NL4. And of course, the speaker needs to be in biamp mode or active mode. What do they call it? I just gotta go back and look at it. They call it biamp mode. So that's what's going on there. Anyway, there are some serious advantages to the active crossovers. As most people can consider it superior. You have more control at the crossover. You can have tighter filter orders, i.e. steeper slopes on the crossover. You have better control. You can phase align them and put EQ in the circuit. You're less likely to blow up loudspeakers because the energy of the lows aren't going into the crossover. That's going to be some that go to the tweeter. The woofer amplifier is in no way interacting with the tweeter, so that's nice. You're less likely to lose energy, so it's more efficient because passive crossovers get hot, right? They got resistors, caps, and inductors in them, and they get hot. So you're not having that heat issue, so you're less likely to blow them up. And transient response is probably better because the amplifier and the loudspeaker is directly coupled to each other, so you have better bridged impedance, where here they have to actually go through the passive electronics. And distortion is reduced as well. So generally, active crossovers are superior. And once you get into the active crossovers, it's, of course, you're biamping, and that's advantageous. And then it's easier to go all the way to a powered loudspeaker. So there you go. There's the subtleties. I believe I've made it through this slideshow. So thanks for listening. Goodbye.